need internet, that's fine. All right, where are we? We are in Belgrade. This has been a very long trip for me. I gave a talk in Vienna, then Istanbul, then Bucharest yesterday, and today here in Belgrade. And this is the biggest of them. Well, Vienna was big, but it wasn't all PHP folks. This is pretty impressive. I like the stage. Thank you very much to the organizers for inviting me. My talk is online, as always. You can find it there, talks.php.net, my Twitter, @Rasmus. So, I've been doing this forever. I started playing with computers in the 80s, in the early 80s even. Had a Timex Sinclair, VIC-20. I dreamed of getting a 2400 baud modem like this. I was on 300 baud forever and ever, sitting there staring at a Z modem download page on a screen. This is how, for those of you who are younger than me, which is pretty much all of you, this is downloading stuff at 300 baud. This was not pleasant. In the 90s, I kept playing with stuff. I did some work with Gopher, did a bunch of IRC work as well, so before the web. But by late 1993, the first graphical web browser came out, Mosaic. Looked like that. And everyone could see, not just me, everyone could see right away that this is going to be huge. And there was a huge scramble to figure out how do we solve the web problem. Everybody had different ideas. Lots of companies tried to get in there and extract rent from the web, basically say, if you want to put stuff online, pay us. And I didn't want to pay anyone to put stuff online. I didn't think anyone should pay anybody anything. So I started building stuff. And my first couple of things I built were all CGI programs written in C. Really not a convenient way of building a website. Anytime you had to change even a slight bit of HTML, you had to recompile your C program, redeploy it, and CGI was slow to begin with. 4 connect sec, a CGI process is way too slow. Now the rest of the world moved to Perl by late 93 using CGI PM, which is a Perl module to build CGI programs. The same program, it's just a form with a name and an H field. Looked like this in Perl. I really didn't like that approach either, because you're still programming your HTML. I wanted the HTML to look like HTML. So I wanted that form to look like this. So you just have simple HTML with a few magic tags in there. And the big thing that really caught on for people and why people started using PHP was the fact that if they put form fields in, they would magically have a variable of the same name. So if you have a form field named name, you get $name available to you in your template. And that was sort of the big selling point. So these request globals that everyone hates today, that was really what made PHP back in the day. Now, that was sort of the front-facing part. The back end that I was trying to pitch to people was that you should write all your business logic in C, statically type, compiled language, and then you just expose your business logic via this very, very simple templating system that I built. Nobody liked that idea. This was sort of my big view of this is how we should solve the web problem. Write all your business logic in C, but let me provide you an API that hides all the complexities of talking to the web server and doing all sort of the boilerplate HTML web type stuff. But still, write your business logic in C. No chance. Nobody wanted to write C code. The web was growing way too fast. There weren't enough C developers. Everybody wanted to use my stupid little templating system to write all their business logic, which kind of confused me. Like, why? Why would you write business logic in this very crappy templating system that was only supposed to be for display logic? But they did. And I kind of just had to go with it. In order to get actual stuff working, there was way more to it than just the templating system and the PHP backend. You had a whole ecosystem to worry about as well. Back then, you didn't have MySQL. There was no good free database to use. There was something called Postgres 95 by early 95, but it crashed. Every time you touched it, it would crash. It was really, really unstable. Oracle was around, but it was way too expensive. I found a little database out of Australia by a guy named David Hughes called MSQL, Mini SQL. It worked really nicely. But computers back then were pretty slow. 32 megs of memory was a lot of memory. My home PC had 8, but my huge server in the office had 32. There was no 100 megabit Ethernet. And the data volume was not necessarily any smaller. You still had lots and lots of stuff to deal with, and huge databases as well. So when this mini SQL database I was using, when I did a select star from logins, if there were too many fields or too many entries, rows in that column or in that database, it could take forever. You're sitting there waiting for all the data to come across the socket from the database server, and it was chewing up my server memory, and in the end, I'm only going to display like the first 15 and then say next page and show the next 15. And there was just no way of doing that in the database. You had to select everything every time and then just pick out the rows that you wanted. It was very, very inefficient, and the latency was in the tens of seconds every time you hit this page. So I hacked up Mini SQL, and here's the commit message when he finally merged my patch. So this is where he merged in my limit patch in October 1995, which was my hack on Mini SQL. Now later on, and this kind of took off. People were using PHP with Mini SQL, and it was getting some traction. Later on, I think in late 95, maybe 96, the MySQL guys came along, and they asked me, hey, can you add support for MySQL in PHP? It's like, whatever, I've never heard of this MySQL thing, what the hell? Why should I bother? It's like, well, we've made it easy for you. We have completely cloned the API of Mini SQL, so you just have to do a search and replace in your editor from MSQL to MySQL, and you'll have MySQL support built in. Okay. But I told them, well, what about this limit hack? All my SQL queries have limits on them. That's not going to work in MySQL. It's like, well, okay, we'll add that. Okay. So this is where the limit clause came from, which is in MySQL and Postgres and everywhere now, which I think is kind of cool. So the point of all this is that there was more to PHP than just the language and the templating system. It was more about the ecosystem, making all the pieces fit together. The Apache module that made it fast to invoke PHP, so you didn't have to fork an exec process. And a lot of work with shared hosting ISPs to make sure that they could safely run PHP and provide it to all their customers. So, enough about 25 years ago. Today, PHP 7 is out, which has been a massive performance boost. Also functionality boost, but mostly performance boost. It's way, way faster than PHP 5, uses a ton less memory. We started off trying to build a JIT, or Dimitri did in St. Petersburg. He wrote a JIT, it didn't really help. So we had to circle back and try to figure out, well, why the hell didn't the JIT help much? And with a lot of profiling, with some help from Intel, we figured out that we were just shuffling too much memory around. So the project shifted gears away from the JIT. Instead, it focused on decreasing the overall amount of data that we needed to run scripts, making sure that the data was in the right place, on the right cache lines, so we were not busting CPU caches, and lots of optimizations. My favorite one is being able to cache immutable arrays in opcache. So this little script here, which is 100,000 arrays of arrays, in PHP 5, that takes 109 megabytes. PHP 7 without an opcache, because our data structures are smaller and the various pieces or smaller, it shrinks to 42 megs. But with opcache enabled, it goes down to 6 megs because we don't have to allocate per process anymore. We can allocate it once in shared memory, and then all the processes can just use that. So there's no incremental memory increase per process. So effectively, we've gone from 109 megabytes to 6 megabytes for this little script, which is a huge difference. And there are lots of other optimizations that we made in PHP 7. The JIT project, still there. It's been rewritten for the new PHP 7 architecture. It's still not showing a whole lot of benefit, but with some more work on it, hopefully at some point. It's not going to be in 7.2. If we have a 7.3, I doubt it'll be in that. If we see it, it might be in PHP 8 at some point in like 2019. The real-world effect of all this work, if we look back to like 2009, this is WordPress 4.8 alpha, running on PHP 5.3, 154 requests per second was what we could get out of it. With PHP 7, we're getting about 476 requests per second. So you get a good 3 times increase if you're running PHP 5.3 by upgrading to PHP 7.0. And then we have had some incremental increases in 7.1 and 7.2. Dimitri has a new hybrid dispatcher that he's very proud of. Hasn't helped that much yet, but it does give a slight boost. There's some other tricks you can do. I like building an FDO binary. FDO is a GCC trick that does feedback-directed optimization, meaning it's a GCC feature, and you can teach your PHP about the code that you're going to run. So you can train PHP to run your particular style of code. So for WordPress, you can build PHP yourself. You can say, make profgen. That generates a profiling version of PHP. Then you train that profiling version. The easiest way is to run PHP CGI minus capital T and say, run this 1,000 times. In this case, I'm running the WordPress front page. And then you say prof clean, make prof use. And prof use then uses that profiling data and creates a new binary. And you can see here the difference between the FDO and the non-FDO went from 504 to about 540 requests per second. So 7% increase or so from one to the next. Note this only works if you have a very sort of single app style setup. If you're an ISP running all kinds of different stuff, you wouldn't want to do this. But if you're a single app shop, there's really no reason not to build your own trained binary because you can squeeze a little bit more performance out of it. As nice as the extra performance is, what's even nicer is that it uses so much less memory. For everyone who hosts in the cloud, when you're paying your bill, you realize that memory is actually the limiting factor. That's really what's expensive in cloud hosting. By upgrading to PHP 7, you can drastically reduce the size of your instances that you're paying for, and you can turn half of them off even. So your hosting bill is going to go way down. And here we can see WordPress running under 5.3 needed about 140 megs of memory. Under PHP 7, exactly the same code needs 15 megs of memory, right? Completely insane, the drop there. It's almost 10x less memory needed to run the same code. At Etsy, we upgraded to PHP 7 a couple of years ago. We dropped about 200 milliseconds in latency. So these are the PHP 5.5 servers, and these are PHP 7.0. Perk 95 response time dropped about 200 milliseconds. CPU dropped about in half. And memory needed dropped from about 80 megs down to 12 megs of memory required to run these. And when I was upgrading, I turned off a whole bunch of servers. The ops team at Etsy was getting a little nervous once we had turned off half the servers, and I kept turning off servers. And I was like, whoa, what are you doing? Please stop. So in the end, we ended up only turning off about a third of the servers, just because We already had the servers. We wanted to leave ourselves some headroom. But we could easily have turned off half the servers and still have exactly the same performance. Which brings us to saving the planet. If we do a little bit of math on this, every server, so there's about 2 billion sites on the web running on 10 million physical machines, and PHP should be on at least half. It's probably conservative. In some way or another, it's probably on a lot more than half, but let's say just half. At 5% adoption, that means PHP 7 is running about 250,000 physical servers. Each server eats up 3,000 kilowatt hours a year, cost about $400 for that power for the year. Then you have to cool that, which is another $400. And you spit out about half a kilogram of CO2 per kilowatt hour, which is quite a bit. At 5% adoption, where we're already at, it's saved people about $200 million, 750 million kilowatt hours of savings, and a lot of CO2. At 100%, those numbers are way more impressive. I have a 15-year-old son. I would like to leave him a planet that's in better shape. So if for no other reason, if you're not on PHP 7 already, damn it, get on PHP 7. For my kid and for your kids as well. And at the same time, if you're having any kind of pushback from management in your companies, tell them that you can cut your serving bill in half easily. That will pay for any work needed to do that migration to PHP 7. I promise. All right, so this year's PHP is PHP 7.1. There hasn't actually been that many changes from 7.0. It's a minor feature release. It's not a whole lot faster, slightly faster than 7.0, but not significantly. And it has a few extra features that weren't ready for 7.0. One of them is a void return type. PHP can't actually return void. It is still null behind the scenes, but this allows you to catch, to specify, I don't want anyone using the return from this function. So you say it returns void, and then the type system can tell you if you're trying to use that return value. And you also get a fatal error if you try to return something from a void function. Nullable types, this question mark here, both on parameter types and on return types, specifies that you can either return null or that type. There's an iterable pseudotype, so for things like arrays and array access objects, anything you can iterate over, you can specify that the function takes an iterable. There's negative string offsets. So just like positive starts from the left, negative starts from the right. The first one is -1. Yesterday, someone asked me, why isn't it -0? I was like, whoa. That was kind of a blow my mind moment that he wanted like positive zeros to start from the left and negative zeros to start from the right. Like, no. List keys. So basically, you can leave off the list keyword. You can use square brackets on the left-hand side of a previous list expression like that. And there's now a warning about arithmetic strings, or invalid strings when you're doing math on strings. Now, this is I'm surprised how often this comes up. In the Etsy code base, I've seen it a bunch of times, and it's because people are confusing JavaScript and PHP. In JavaScript, to concatenate two strings, you use a plus. And a lot of people just reflectively do that in PHP, and it's obviously a bug. They didn't mean to try to convert the two arguments to ints and try to then mathematically add them. So this notice is now catching a lot of bugs, at least in our Etsy code. Maybe our code is way messier than everyone else's, but I predict this will catch some bugs in your code as well. You can add visibility to your class constants. And just a few things that will break your 7.0 code. If you have a class named void or iterable, you have to rename it. Rand is slightly different. The rand function now actually is just an alias for mtrand, and even mtrand will return slightly different random numbers, which really shouldn't matter. they're random numbers, right? So it shouldn't matter that there's a different sequence of random numbers. The only time it might matter is if you have some kind of test with a known seed and you're expecting a certain sequence of random numbers. You're going to have to regenerate those random numbers and fix your test. And we dropped support for mcrypt. Unsupported, dead, old library. Don't use it. Upgrade. Either OpenSSL or there's a new extension coming called libsodium. Either one of those. But for now, OpenSSL functions can replace anything you need from mcrypt. All right, a side project of mine. I started a project called FAN to do static analysis. Initially, it was just to help the migration at Etsy from PHP 5 to PHP 7. But it has grown beyond that as things that I do tend to do. Not because I do it, because other people have piled on and started making it better. It can catch stupid mistakes, like this one. I mean, this code might look okay, and you run it, there's no syntax error or anything, but the author obviously didn't mean to do count on this expression. He probably meant to do count A, bracket greater than 1, right? So this can find this and say you're doing a comparison from an array, and you're comparing an int to an array directly, which you probably didn't mean to do. It can check PHP doc comments. So as most people's code, their doc comments are wrong. Or at least maybe they were right at one point, but then the code changed underneath them. FAN can make sure that your doc comments are actually correct. It can help a bit with refactoring, because you can mark stuff as deprecated and then catch all the callers. It's easy to install. You can compose or require it. There's a config file where you can set various things. Normally, you want to do something like this, saying, these are my directories that should be scanned, source and vendor. And then you can tell it, don't analyze the vendor directory. Just analyze my code, but still read the vendor directory to get all the objects and everything loaded in, but only analyze the source directory. So this is sort of the default config. And then you can run it on your code with vendor bin fan. Very simple. I think you can also use it to get to better type safety in your code. So if you have code like this, completely untyped, if you just started putting types on everything, so you put types and strict types on, array here, return types, you're going to end up with runtime fatals in production, which is going to be on a huge legacy code base. It's just a non-starter. You can't just add types everywhere because the code wasn't written to be typed. So if you really want that code to have stronger types, you have to have sort of an intermediate step. And I think that's where FAN can help you. If you put in essentially soft types via doc comments, you're not going to get production fatal errors, but FAN can check your code and at least catch some of the cases where your types don't match your expectations. All right, how am I doing on time? Not well, okay. So, I wanted to leave a few minutes for questions. I know I don't have a lot of time, but do we have a mic in the audience? Yeah, we do have mics in the audience. So, oh, first question from a speaker. Damn, we need some attendees too.
So I was just going to ask a question about the FDO binaries.
The
Would
FDO.
it be worth making binaries for specific frameworks like Zen or Symfony, or would that not really give you any benefit?
So should you build like a generic Symfony optimized? I don't know. You'd have to test if that really helped. I suppose it could. Depends. I think it would depend on the type of app you wrote against Symfony or against Laravel. I think you're better off writing your app and then doing the training once you've actually implemented your application. But yeah, an FDO, a Laravel FDO binary would be slightly faster, I would assume. But it would be even faster to run it against your actual implementation, I think. But we're talking like 1, 2, 3% here of like a Laravel FDO binary. I'm not sure the hassle is worth it for the Laravel project to do that, but who knows? Others? just shout and I'll repeat it.
Whoa. Okay, a bit better now. I will be short. Where can we expect the generics in PHP?
Generics. So there has been some discussion about generics. It's going to have to wait for a decent implementation. Before the PHP 7 rewrite of the internals, it just wasn't possible, or at least extremely hard in the implementation. In the PHP 7, it's possible now, but I wouldn't expect it anytime soon. I haven't seen a plausible RFC for it yet, and definitely there is no plausible implementation for it yet. So not in 7.2, maybe in 8.0 if someone steps up and does the work, but we'll see. It requires a whole lot of work from a couple of people. It's hard. It's an open source project, and we get the features that people volunteer to write.
So you mentioned the potential release of PHP 8. We're expecting a new major version every 18 months, 2 years, or is it different?
Well, a major version, we don't have a real plan for the major versions. The major versions kind of come when we do come up with some major feature. So if no major features come up, we'll have every year we'll have a new, so we'll have 7.3 next year, 7.4, 7.5, 7.6, until usually either Dimitri or Chin Chin or Nikita says, okay, I'm going to change the world. And we look at it and go, okay, that's a good idea, let's do that. But we're going to have to make it 8.0 because all the extensions will have to be fixed and stuff. In the dot versions, minor versions, extensions they have to be API compatible, so you just have to recompile the extension and it will work without any changes. If you have to make major changes to extensions, we bump the major version. And that's usually only when someone does something major in the internals, like perhaps generics, perhaps the JIT, something that really affects the entire internal API. Then we'll jump to a major. And we don't have a set schedule for that part. I have 20 minutes still? Really? Okay. Not sure how that works in the schedule. Yeah, I do prefer the question part, which is why I try to get to this part quickly. Yes?
Okay, so I relatively frequently check what's going on in the rfc.php, the wiki page for RFCs.
Mm-hmm.
And I know that you have a voting stuff going on there and deciding on features and stuff.
Mm-hmm.
And I was really wondering, is there a way to have a better insight on what's going on and what the reasons for declining or accepting a feature are and stuff like that? Really haven't found anything on the topic.
So most of the discussion happens on the internals mailing list, and the authors of the RFCs are really supposed to update the RFC with either links to the mailing list or a summary of both the points for and against. But historically, we haven't been very good at circling back and updating the RFC to put the arguments both for and against into the RFC itself. So that information is kind of spread out over mailing lists and different mailing list threads. And sometimes people even discuss it in like chat rooms or in person at conferences and stuff. So it is a bit hard to pull together both the reasons for and against some of these RFCs. Many times an RFC is rejected, not because we don't necessarily like the concept, but because the implementation is terrible. And that's hard to tell if you don't know the internals of PHP, if you're just sort of looking at it, hey, that would be a great idea to have this feature. Yeah, but then we look at the internals and it's like the actual implementation is just horrible and it will kill performance. It affects all kinds of things it shouldn't be affecting, and that's why people vote against it. So there are many, many reasons people vote against things, and I think people who are looking at it just from the outside, only at the RFC level, don't necessarily appreciate the fact that there are other reasons than just the feature itself for voting against an RFC.
Okay, one more question that maybe not adequate for you, but for Google, but still hadn't had a lot of luck. Where can we get some like decent documentation on, or is there any about how actually Twitter works and what's going on in the internals? Do we clone the repo and read T code?
Right. So our internals documentation isn't great. We do have some. There's on the wiki itself, if you don't go to the RFC part of the wiki, on the wiki itself, hold on, I should have connected earlier. On the wiki itself, on the top level, just wiki.php.net, there is a very good document on PHP-NG, which stood for PHP Next Generation, which is essentially the PHP 7 implementation, and it shows everything that changed from PHP 5 to PHP 7. But really, if you're writing stuff, if you're writing C-level code, your best bet is simply just to look at all of PHP, because all of PHP is written against that internal API. So every feature in PHP is basically an extension, and your extension is going to look exactly like the MySQL extension or the whatever, the LDAP extension. Any one of those extensions bundled with the core is sort of a definitive example of how to use the API. So you take one of those that are closest to what you're trying to do, and you just grab ideas from there. But there is documentation on the wiki, like I said, but it's not great. We only have a handful of people that know enough about the internals to write that documentation, and half of that hand don't speak English, or at least not very well, and the other half don't like writing documentation. So,
Wait, can I get one more last?
Wow, that's a lot of questions for you. All right, last one.
This one is rather on the like generics the question. It's
Okay.
what about class friendship? Are we going to get that,
So
or
friend,
something like it?
So you're asking about friend classes.
Yeah.
There has been a bit of talk about that, but there's a lot of passionate opinions both for and against friend classes, and I'm skeptical that we can come to an agreement on friend classes. Others? Really?
Okay, hi. Just a simple question. Do you have any plans about implementing native async support in future PHP?
Native which support?
Async.
Async, oh, okay. Well, we have lots of async support in PHP, but if you're asking about being able to start like a thread in PHP itself, no, there's no plans to do that, mostly because it would complicate the internals of PHP by a ton without any real benefit. You really should not be running multiple threads on your front-end web servers. If you have stuff you need to run async, then, I mean, if you're just sort of, if you want to hit multiple sites, for example, if you want to go and hit a whole bunch of external APIs, that's not an async thing, that's, well, it's async in a sense, but it should be an event-driven thing, and we have lots of support for event-driven stuff. You can just open up all the FDs, run select, and as the events happen, you can get them. So simple stuff like that, we already have supported. We don't need anything else for that. If the async you need is sort of to run a whole bunch of PHP code asynchronously, then you're much better off farming that off to some kind of request queue mechanism like Gearman, for example, and have those run on a separate server and not tie up your front-end web servers. Your front-end web servers are busy enough taking requests. You don't need threads in order to use up all your cores. So you're better off farming that off to a set of servers that actually run these async requests. So I know it's a bit of a cop-out saying that you shouldn't be doing it that way, but it's, in the web sense, for a web architecture type of thing, it really is true. You shouldn't be running this stuff on your front-end web servers. If you have heavy jobs you need to run asynchronously, run them somewhere else and collect the result when they're done. There are times with CLI type stuff, for example, FAN, the static analyzer. running a program from the CLI, it's really handy to have multiple threads. And from CLI, you can run the PCNTL, and there's also a threads extension that works from CLI. And there you can run threads. There's a -J argument on fan. You can say fan -J8, and it will run 8 parallel fans and spread the work of analyzing your code. So from the CLI perspective, you can do that stuff already. But no, I don't see native async coming to the core of PHP anytime soon, unless we do it unless we have a tricky way of doing it. I know Nikita and I have talked a little bit about a tricky way of doing some stuff there. I don't know if that's going to go anywhere, though. Yes.
Hi.
Hi.
My name is Alexander, and my question is related to previous one. I want to ask your vision about changing PHP from shared nothing to shared concept. For example, we have applications based on Symfony framework, and time for container initialization is very huge. So will it be possible to share container instance between several requests and keep it warm, and don't spend our time for initialization, for preparing our counter?
It's a bit of a tricky question. The startup cost so I mean, at the application level, you're saying that there's a high startup cost because you have to load in objects and stuff. PHP 7 transparently caches all this stuff in opcache. Now, you're saying, can you split it across multiple containers? And that's a problem because your opcache is inside your container. You don't have a shared memory segment outside your containers in that case. So in that case, you're not sharing. So if we're just talking within one container, PHP actually does all that caching for you already. Objects, arrays, everything is cached. There's an intern string cache as well that even caches your strings and stuff. So the startup cost is minimal within that one container. But sharing this across multiple containers, it would be possible if we created the opcache shared memory segment slightly differently, right? So we could, instead of doing an anonymous file-backed shared memory segment, which once you start it up, you can't access it from anywhere else. It's only the process that started it and any children that can see it. If we did a non-anonymous shared memory segment, then it could just be a file in the file system, and you can configure each container to point to that same shared memory file. So it wouldn't actually be that hard to do. The reason we don't do it is because if you do it that way, if PHP goes away, that shared memory segment is going to sit there still. So if you have a 1 gig segment, every time you start PHP, it's going to make a new 1 gig segment. And you can easily take the server down, but basically there's no more memory on the server now if you don't realize that your segments are leaking. When you have an anonymous file-back segment like we do, as soon as the process dies, the operating system will clear that shared memory segment. So that is by far the safest default. But you're right, I mean, and we have looked at it, it wouldn't actually take that much. It would be a minor change to the piece of opcache that creates the shared memory segment to actually have a non-anonymous version of that. You can make that change yourself. It's very simple, but yes, we probably should look at that. Put in a feature request or put a little RFC together and explain exactly why it would be useful to have non-anonymous shared memory. It's not a bad idea. I've thought about it before, but I never thought about it in terms of multiple containers sharing the same thing.
Testing?
Oh, there you go.
There we go. Thank you. Less technical question for me. So more about your day-to-day roles at Etsy. Do you get to write any code, or do you spend most of your days reviewing pull requests?
Do I get to write code? That's funny. As if someone could stop me from writing code. Yeah, I write code all the time. Not always code that's useful to anyone, especially to Etsy. No, my day-to-day stuff is I help out sort of across Etsy. I'm kind of a floating engineer that looks for interesting problems and tries to solve them. Help a bit with architecture here and there, help with security stuff, and track down tricky problems. Once you reach a certain size in the company, there's always weird stuff going on. Like this weird error message that only shows up once a week, for example, and everyone's just, well, it only happens every now and then, who cares? But eventually, someone needs to care and try to figure out what is actually happening here. What assumption did we make that was wrong that's causing this thing to break every now and then? And some of these things, at least at Etsy, we have a lot of young engineers in their early 20s. And they don't have the background, and they don't have sort of the overall breadth of knowledge to look all the way down the stack, all the way into the kernel, to try to figure out why something is breaking. And then, the other day, we had a process, a Linux process that was stuck in this D state, which is this killer state where you can't kill it. You can't kill -9, you can't do anything. It was holding open a log file. So other jobs coming in, trying to do their job, looking at the log file, going, okay, this process has the lock, I'm going to wait. But I was sitting there waiting forever because this other process was dead, but you couldn't kill it. The only way to fix it is to reboot the machine, which sucks. And trying to figure out why that happened was really, really tricky. And it turns out, and I didn't figure this one out, another colleague of mine who's sort of in the same role as me figured out that this was a bug in the NFS part of Linux, in the NFS code, which was fixed in January of this year. But getting right down deep into this, to the operating system like that, it takes someone who's been around for a while and has coded at that level. So that's kind of what I do. I fix interesting problems just because because I'm old, basically. Not because I'm smart or anything, but because I've been around a long time and I've had to hack at many, many different levels. So every now and then I see a problem, go, I know what that is, because I did this 8 years ago or something, right? So. I saw another hand, maybe I didn't. I think we have time for like 2 or 3 more. There's one here.
What are your thoughts on and how realistic do you think that are these approaches to building an application server, so to speak, in PHP, things like PHP PM that have been gaining some popularity, more for experiments, I would say, so far, where you basically have one PHP process that handles a large number of requests?
Yeah. This takes me back about 15 years where everyone wanted an application server, and I fought against that so hard. The problem with application servers is that you can't scale them. When everything is shared nothing, and you have a perfect sandbox where you tear down everything you created at startup, it means that you can scale horizontally forever. You can just add more instances next to each other, and there's nothing stopping one request from hitting this server here, and the next request in the same session from being that server over there, unless you've screwed up your session backend yourself. But in PHP, there is nothing that stops you from scaling horizontally. Once you have an application server, the only reason to have an application server is to maintain state, essentially, in the application server itself. So you can start off this big, complicated application that initializes all kinds of crap, and then it sits there waiting for requests and serves up stuff. That's great, until you need to move it to multiple machines, and then you need to find a way of then sharing that state. And it's just not something that belongs anywhere near PHP. If you want to do it in user space PHP, great. And you can run long-running PHP processes. That's why we have the garbage collector. So it's actually feasible now, if you don't turn off GC, to make this work. But no, at the PHP project level, I don't see us ever looking at application server stuff. Yeah.
Speaking of turning off GC, are there any plans to make Composer or like the official standards for dependency management in PHP?
No, I mean, it's essentially the default now, right? I mean, it's the standard that everyone uses, and it's not really, I don't think it's the job of PHP to sort of anoint different technologies as the standard, right? I know we shipped the pair client for a while, or we still do, I guess. So in that sense, I guess it's not quite right. We have done that in the past, but I think Composer is doing quite well on its own. I don't want to add any additional burden to the project. If it starts falling apart and not working at all, then we can help. I have offered our whole, is Jordi here? He's not here yet, he's still drunk, I think. You'll see Jordi later. But I have offered, like, we have a big worldwide distribution of servers, that mirror servers all over the world. And I think it would be interesting to distribute the back end a bit of Composer. And I have offered the whole PHP.NET series of mirror servers for that. But there are some technical blocking things that makes it not distributable, I think. I didn't quite understand Jordi's explanation for why he couldn't do that. But other than that, no. So I don't think we need to get in there and say, okay, this, you should be using Composer. I mean, we say that anyway. But I don't think we need to sort of officially do anything from the PHP project in that sense. How much time do I have? We're out of time? 5 minutes, okay. Cool, one more good question.
Working. Oh, yeah. So, what does it feel like knowing that you created something this big? You might not like this question, but...
No, you know, I don't... The reason I don't like the question that much is because it wasn't me. It was a whole bunch of people in this room as well.
Yes.
It was hundreds and hundreds of people have created this over the years. I happened to start it, which was just a fluke. It's like I always say this, I mean, it's like when you go to a party and the party turns out to be great. Everyone shows up and it's really a cool party. Is that because the first person who showed up made that happen? No. The first person who shows up at the party is usually not very cool at all. Right? The party becomes cool because everyone joins in and everyone shows up and all the cool people show up to the party, right? And that's essentially what happened in the PHP project. I happened to be at the right time, at the right place with a workable idea. But my code was horrible. You can ask anyone in the PHP project who's worked on internals, who's had to deal with my code. They'll tell you, look, he is a terrible programmer. And I am. I fully admit I am not a good programmer. But there are lots of even worse programmers in the world still. But I am not a good programmer. I have some good ideas, and I am just good enough of a programmer to get those ideas started and working. But without all the help over the years, there's absolutely no way PHP would be where it is today. So when you say, how does it feel? It's, okay, it feels lucky. Other than that, nothing else really. I don't feel like PHP is mine at all. I am simply another contributor to the project. One last question, I think. There's one very highly raised hand right here.
Hi. All right. Hi. Just about what you've got on the screen right now. The
okay.
Yeah, like using fan to look at legacy code and see if it's kind of well typed.
Mm-hmm.
Wouldn't it be nicer if we could just turn the fatal errors into warnings and then just run the code?
So Nikita and I were in Istanbul a week ago, and we had that exact discussion. We were saying, well, maybe we could have another mode. So instead of strict types equals just 1, maybe we have another mode 2 or whatever, where it's not a fatal error. It's not a bad idea. I kind of dread the discussion that will incur if one of us brings it up on internals of having this yet another type mode. There's going to be a lot of reasons not to do it. I mean, there's an obvious reason to do it, but there's also going to be a lot of reasons not to do it. So, yeah, I don't know. I mean, Nikita and I talked about it, and it's not a terrible idea. So it could happen. It could happen. I know it's a wishy-washy answer, but I don't know. I don't know how that would go. I haven't thought it through enough to have a great opinion on it. Are we out of time? We're out of time. Thank you very much.